Hello everyone, here is a question based on structural isomers and structural isomerism. Write all the possible isomers of molecular formula C4H10O and identify the isomerisms found in them. Let us first determine the degree of unsaturation for this elemental composition. Degree of unsaturation is equal to 1 plus number of carbon atoms minus number of hydrogen atoms by 2. Oxygen atom doesn't participate in the degree of unsaturation calculation and therefore we can omit them. Therefore, this is equal to 1 plus 4 minus 10 by 2. So, this is 5 minus 5 and that is equal to 0. This means this is a completely saturated elemental composition and we don't have to worry about carbon-carbon double bonds or carbonyl group. This means no aldehydes and no ketones. So, these two things are also no. So, with the oxygen atom, what are the functional groups we can make? We do have hydrogen, we do have carbon. We can make alcohol as a functional group. So, we can write structures of alcohols and we can also write structures that corresponds to ethers. So, these are the two things that we can write. One is alcohols and another is ethers. So, these two things we are going to write for this elemental composition. I am going to write all the structures in condensed form and also the corresponding structure in bond line notation. Number 1, we can write butane 1-ol, that is CH3, CH2, CH2 and then again CH2 and then OH. This is butane 1-ol. And the corresponding structure in bond line notation is 1, 2, 3, 4 and then OH. I have seen that sometimes students write it this way, which is wrong. They think that this is carbon. No, this is not carbon. Once you write structures like this, then what it means is that this is propane 1-ol, not butane 1-ol. So, this is 1, 2, 3. This is your carbon oxygen bond. So, when you are writing OH, please make sure that you have 4 carbon atoms, not 3 carbon atoms. This is something you need to be careful in bond line notation. Let me just remove this. So, this is butane 1-ol. And then number 2, we can also write butane 2-ol, that is CH3, CH2, CHOH and then CH3 and the corresponding structure in bond line notation will be 1, 2, 3, 4 and then OH group at second position. This is butane 2-ol. We can't write butane 3-ol because if you start numbering from left to right, then it would become butane 2-ol once again. So, no butane 3-ol. We are exhausted with the butane chain. Let's go to the propane chain. And then number 3, we are going to write 2-methyl propane 1-ol, that is CH3, CH, CH3 and then CH2, OH. And the corresponding structure in bond line notation will be 1, 2, 3, 1 methyl group at 2 position and then 1 OH group at 1 position. Let's number it 1, 2, 3, 1, 2, 3. So, this is 2-methyl propane 1-ol. And then number 4, we can also write 2-methyl propane 2-ol, that is CH3, C and then OH and then the methyl group and then again another methyl group and the corresponding structure in bond line notation will be 1, 2, 3, second position OH at the same place methyl group. This is 2-methyl propane 2-ol. We are exhausted with the propane chain. We are exhausted with the alcohol isomers also. Therefore, let's go to ethers. Number 5, we are going to write methoxypropane, that is CH3 and then O, and then CH2, CH2, CH3. And the corresponding structure in bond line notation will be 1 and then oxygen and then again 1, 2, 3. Let's number it. This is the long continuous carbon chain 1, 2, 3. So this is basically 1-methoxy propane, 1-methoxy propane. And then number 6. We can also write ethoxy ethane, that is diethyl ether, CH3, CH2, O, and then again CH2, CH3. And the corresponding structure in bond line notation will be 1, 2, and then oxygen atom, and then again 1, 2. So this is ethoxy ethane. And then number 7, we can also write 2-methoxy propane. That is basically on one side methyl group, and then on the other side we have an isopropyl chain. So CH3O, CH, and then CH3 and CH3. And the corresponding structure in bond line notation will be 1 and then oxygen atom, and then 1, 2, and then put a methyl group here. Let's number it. 1, 2, 3. That is the long continuous carbon chain. And therefore, this is 2-methoxy propane. These are the 7 isomers that we can write for C4H10O. Now let's talk about isomerism among these 7 molecules. But before I begin, let me just say that molecule 2 has a chiral carbon, but we are not talking about stereoisomers here, and therefore let us not worry about stereoisomerism for the time being. Now, any comparison of 1 to 4 with 5 to 7 would become functional group isomerism, isn't it? Because in 1 to 4 we have alcohol as the functional group, whereas 5, 6, 7 has an ether functional group. So any comparison of 1 to 4 with 5, 6 and 7 would be a functional group isomerism. If we are comparing 1 and 2, then what is the isomerism there? We have the same functional group, parent chain length is also same. In the case of 1, the OH group is attached at 1 position. In the case of 2, the OH group is attached at 2 position, isn't it? So therefore, this is clear case of position isomerism. So therefore, comparison of 1 and 2 is a clear case of position isomerism. How about 1 and 3? If we are comparing 1 and 3, then it is a chain isomerism, because in 1 we have butane as the parent chain, whereas in 3 we have propane as the parent chain, and therefore 1 and 3 are chain isomers. How about 1 and 4? 1 and 4 are also chain isomers for the same reasons. How about 2 and 3? 2 and 3 are once again chain isomers because the parent chain length is different. How about 2 and 4? 2 and 4 are once again chain isomers. Parent chain length is different. How about 3 and 4? When it comes to 3 and 4, they are position isomers because the parent chain length is same now. The alcohol functional group position differs, and therefore 3 and 4 are position isomers. How about 5 and 6? 5 and 6 are metamers. 5 and 7 are also metamers. 6 and 7 are also metamers because 2 different alkyl groups are attached. So here we have a methyl group, whereas here we have a propyl chain. When it comes to here, we have a ethyl group and then we have a ethyl group on the other side. So the alkyl group units are different, and therefore, so if you are comparing 5 and 6 or 5 and 7 or 6 and 7, they are all metamers. Some students do ask this question, why 5 and 7 are not position isomers? So in that case, you need to remember the order. Even though 5 is 1-methoxy propane and 7 is 2-methoxy propane, it would appear like position isomerism. But you need to remember the order for the isomerism. That is, ring chain isomerism takes the top precedence, and then tautomers, and then functional group isomers, and then metamers, and then chain isomers, and then position isomers. This is the order that you should follow. Whenever you have confusion, this is the order to follow. So therefore, if you are comparing 5 and 7 in this case, then they are definitely metamers. We shouldn't call them as position isomers.